In this video, we are talking about direct variation. Direct variation is when you have your two variables and they vary directly with one another. So there are four ways that you can see a direct variation represented. You can see an equation, a table, a graph, or you could be given a word problem. We're going to start with the equations. So if you have a direct variation equation, it's going to look like a linear function without a y-intercept listed. So it's y equals k times x, where you could also think of k as m. So instead of y equals mx plus b, like a linear function, it's just y equals mx or kx. Now we use the specific parameter k because k represents what's called the constant of variation. So the constant of variation is more or less the slope or the rate of change of that function. So in other words, a direct variation equation tells you that y is always equal to some value times whatever x value you're given. Right now, just like I said, this is a linear function because the equation has a constant rate of change. So that constant rate of change is very important for a direct variation function. That just means that it's always changing by the exact same amount. Now let's talk about the tables. So a direct variation table is just a linear table, but it has to go through the origin. In other words, it has to have the point 0, 0. So for this table, if we wanted to know if it is a direct variation, we would simply need to see that it has a constant rate of change. So a constant rate of change means that your y values are changing by the same amount each time. So we can see here that from -2 to 0 is adding 2. From 0 to 2 is adding 2, and so on. 2 to 4 plus 2, and 4 to 6 is plus 2. So in this case, our table is a direct variation because our y's are changing by 2 and x is changing by 1. So we're just increasing by 1. Now that means that we have a constant rate of change because our change in y over the change in x is the same constantly. Every time our y changes by 2, x changes by 1, and so on. So since they're all the same, it's a constant rate of change, and it contains the point 0, 0. Okay, so if you wanted just to quickly be able to find the constant of variation or the constant rate of change, you would look for that slope or the rate of change, which is our change in y over the change in x, where the change in y, we said they were going up by 2, and the x's were going up by 1, and that just simplifies to 2. So in this case, 2 is our k value. All right, now let's look at graphs. So the graph of a direct variation, again, it is a linear function, so it's just a straight line that passes through the origin. So it's very important that it passes through the origin, otherwise it's just a linear function and not a direct variation. So you have here that this example is just a graph that has a positive slope going through the origin, but it could be a lot steeper than this. It could be a negative slope, so it could look like this, or it could be a really slow slope as long as it goes like that and goes through the origin. As long as it's a straight line going through the origin, that's a direct variation. And finally, word problems. So this is where it can get a little bit tricky, but there is a process to it, and I think you'll find that it kind of makes sense when you understand that anytime you have a word problem that says that there's a direct variation, you're trying to find the constant of variation k so you can write y equals k times x. So here's just an example. Y varies directly with X. So that right there is step one. It tells us this is a direct variation. So we're going to write down Y equals K times X because we know that this is a direct variation. All right, so if it says that Y is 3 when X is 12, that right there tells us what the constant of variation K is. We just have to solve for it a little bit. All right, so if Y is 3 when X is 12, that was part of the problem. So all we have to do is figure out what is that relationship. So if we know this is a direct variation, Y equals K times X, and we're told that Y is 3 when X is 12, we just plug those into that equation. And then we can solve for K. So in this case, we would have 3 equals K times 12. We're going to get K by itself by dividing out 12 on both sides. So these would become 1. 12 over 12 is 1. And we would just be left with K equals, and then over here, 3 divided by 12 is 1/4. Okay, so both of those are divisible by 3. So 1/4 is our constant of variation. Now we're going to take that, remember that we had Y equals Kx, and we just found that K is 1/4, so we're going to put 1/4 in for K. That's our next step. So Y is always 1/4 times the X value. All right, so let's look back at where we came from here. Right? Y varies directly with X, so Y equals Kx. If Y is 3 when X is 12, so we plugged those in and found that K is 1/4. So our constant of variation is 1/4, and our linear direct variation equation is Y equals 1/4 X. Okay, so now we have this relationship, this direct variation function, and we are asked to find Y when X is 20. So same situation. If we know that this is our equation, we're going to find Y when X is 20. So we're going to plug in 20 for X. So we had our equation, plug in 20 for X, and solve for Y. So 1/4 times 20, or 1 times 20, and then 4 times 1 would be 20 over 4, which is 5. So that's your basic setup of every direct variation word problem. All right, let's look at a few more examples. We're going to start with the equations over on the left. All right, so anytime you have Y equals a number times X, that is a direct variation. Now, as long as you can write it in that form, it's a direct variation, but you might see it written in a different form that is equivalent to this. So Y equals 5X, that's a direct variation, or you may see it written as Y over X equals 5. Well, where did that come from? All right, so let's look back at this equation. I can rewrite this any way I want to, as long as I'm following the rules of equations. And if I were to divide by X on both sides, this becomes 1. So we just have Y over X equals 5. That's still a direct variation. So just showing you all the different ways that you could potentially see these written is going to help you when you are determining if an equation is a direct variation or not. Okay, or you could also see it written as if we did the same thing, but instead of dividing by X on both sides, if you had Y over 5 equals X, that's still a direct variation. As long as it can be written in this form, it is a direct variation. All right, now the second example, Y over X equals negative 12. Well, in this case, I can multiply by X on both sides, and that gives me Y equals negative 12X. So that is a direct variation function. And finally, y equals 1/3 x. That is a direct variation because it's y equals k times x. But you may see it written in a different way. If I multiply by 3 on both sides, I would have 3y equals 1x. That's still a direct variation because it can still be written in this form. Now looking at the tables. To determine if a table is a linear function that is a direct variation, first we need to make sure that there is a constant rate of change. So we want to look at how are the y's changing. So from -5 to 0, that's adding 5, adding 5, adding 5. The x values are adding 1. So there is a constant rate of change, so our k would be 5/1 because it's your change in y over change in x, and it goes through the origin. So since we have both of those items, this is a direct variation. Okay, let's try another one. We have this table where our y values are changing by actually subtracting 7, not adding 7, which is fine. So since they're subtracting 7 and our x values are increasing by 3 each time, as long as that's a constant change, then that's perfectly fine. So our k, our change in y over change in x, is just -7/3. That's still a direct variation as long as it goes through the origin, which it does. And finally, this last one. We have our change in y is going down 1 each time, and our change in x is going up 1 each time. So that is a constant rate of change, but it does not pass through the origin. So this is not a direct variation. And finally, let's look at some graphs. So if you have your coordinate plane, anytime you have a straight line that goes through the origin, whoops, that actually didn't quite go through the origin. As long as it passes through 0, 0, I can't make it happen, but it goes through the origin, that is a direct variation. So it could, like I said before, it could look like a positive slope or it could be a negative slope. It really doesn't matter as long as it's a straight line and it passes through 0, 0. Now, if you have a linear function that doesn't go through the origin, so let's say it looks like this, well, that's still a linear function, but it's not a direct variation because it doesn't pass through the origin. So this would be not direct. And finally, let's look at an example of a word problem. Okay, Sarah's paycheck varies directly with the hours she works each week. So right here, we aren't told X and Y, but what we're told is that her paycheck varies directly with the hours that she works. So it's always going to be Y varies directly with X. Okay, so Y varies directly with X. So her paycheck is Y and X is her hours. So we're going to start with writing our direct variation general function. It looks like y equals kx. Oops, that's kind of sloppy. Right? Now we're told that if her paycheck, let me put this in a different color. So if her paycheck is $345 for working 30 hours, we're going to stop right there and plug in that information. So if her paycheck, which is Y, is $345 for working 30 hours, which is X, we plug those two in, now we can find what that relationship is. What is the constant rate of change between 345 and 30? So to find that, we are going to get K by itself, so divide out that 30 on each side. So 30 over 30 is 1. And that leaves us with 345 divided by 30. So just in a calculator, let's see what that gives us. So 345 divided by 30 is 11.5. So that's our constant of variation. So now we're going to take this constant of variation and write our equation, which is y equals kx. So k is 11.5. And this is our relationship, okay? So she earns, what this tells us is that her paycheck is equal to $11.50 per hour for each hour that she works. So if this is the case, if she earns $11.50 per hour, how much will she earn for working 32 hours? So in other words, what is y? What's her paycheck going to be if her hours is 30? So we're going to take 30 and plug it in for x. 32. All right, so 11.5 times 32. Let's see what that gives us. 368. All right, so that would mean that she's going to earn $368 for working 32 hours. And that's the general setup of any word problem with direct variation that you're going to see. So just give you another glance at all the different types of direct variation that you could come across. And if you have any questions, please let me know.